Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert training. I'm your host, Leandro Humana, and in this video what we're going to see are the basic arithmetic operations that we have in the software. So let's go to the presentation. So as I mentioned before, during this complete model, I'm going to focus only in three different languages: ladder, CFC, and structure test. So as a basic operation, a basic arithmetic operations, I mean these fours, okay, that we have over here: add, subtraction, multiplication, and division. Let me just put this pen, okay. So as you can see over here, compared with the previous function that we saw, this one doesn't have any instance, okay. So there is no need for declaration on the local variables on the GBL for using these function blocks, okay. Just put the function blocks and then you can use it. So as you can see here in the input, okay, we just need to match the variable type that we are going to use. If we're going to use real, then the other variable must be real. If you're using integer, the other variable must be int. If they are not the same, then I recommend you to check for the converters as we saw in the beginning. So if you're using ladder, okay, you have in the toolbox the possibility to have all these functions ready to use, such as drag and drop it, and that's it. Then if you are using the CFC, what you need to do is to have in the toolbox drag a box and put it in one place in the area, and you just type the name of the function block. One thing that you can do is to have, if you right click on the box, is to add the enable input and enable output. So with this you can execute only one time, okay, or you can decide when to execute the function based on this enable that you have over here, okay. Then my recommendation here, if you're using arithmetics or you want to make a calculation or something, then I strongly recommend you to use structure test, so you can easily define all the variables that you have, okay. This is just an example how you can define different variables, okay. It can be done on the same POU, or you can have on the GBL, and then remember to use name of the GBL dot variable, and then you have the possibility to use the icons that you have over here: add, subtract, multiply, and divide, okay. So you can use all these, and the advantage of having this structure test is that I give you the possibility to easily read and type all the formula that you have. So you can see over here I'm using a combination of stuff. Over here all of them are real. You can see on the top bar 1, 0, 2, and 4 are all real, okay. So you can make this, it's going to be much easier, okay. If you're working, for example, in ladder, and then you need to call a formula like this, you can create your own function block or something, then to call it. So now if you're working, for example, this one is CFC, but it can be applied to a structure test. These are the variables that I have already defined, for example, and if you take a look at this one, ibar 03 is a int, all the rest are real. So what we need to do is to use here a converter. So in the add over here, all of the variables are real, okay. So this is the idea in behind. You can see over here I use 5.0 because I real, and I bar just the 2. Then I multiply int with int constant. This one is real, this one is already real. Here the result is going to be real, and this one the result is going to be int, but here based on the converter is going to be real, and here I have the real result, okay. So if you take a look over here, this takes so much time, too much space, and it can be easily done using something like this, using text. So here you need to check if you are, I can understand that probably you are familiar with ladder or the CFC, but sometimes just a small code in a structure test is going to be much easier to see and identify where is the problem, especially in a formula. Okay, and this is how you can use the converter here in the structure tests. So if we continue with this, okay, let's add a POU. Okay, and I'm going to use the ladder. Okay, and then I'm going to quick explanation how you can use, for example, SC, and if you are still using a structure test ladder. So let's go back to the software. So in the software, okay, I have already used this one, okay, but for example, if you go here in the POU, right click, you can activate these actions, which is like a small POU that can use that you can call inside this one. So POU action calculation. Okay, and I'm going to use a structure test. Okay, so what you need to do over here, box, calculation. So this one here, are you going to call the calculations that is here? Okay, what you need to do, for example, is to define the variables. R bar 01, this one's going to be real. R bar 02, and this one's going to be real. Oops, real. And R bar 03, real. And this one, R bar result, real. Okay, if you don't remember how to do this, the easiest way is to change to tabular view, and here you can define, for example, R bar test. Here you can easily change the value for this one, input assistant, and select the type. It's going to be much easier, and then you can go to textual and you can see the variable once again here. So here is the small function block to call this one. So here what we can do is to use R bar. Let me just change something here so I can options, text editor, smart coding, this one. So R, so I can see all the variables, R bar result, R bar multiply by R bar 2 plus R bar 3. So you can separate like this to make the calculation. So let's assign something over here. So this one gonna be the value 2, this one 1, and this one 4. So if we connect now, hopefully there is no error. So now log in. Okay, let's log into this one. Okay, calculations that you can see here, how it out 1 plus 4, 5, 5, 4, 5, 5 times 2, 10. Okay, if I change this to 3, it makes the calculation. Okay, I didn't want to waste too much time on this part because it's easy. Okay, so the important thing is this. Let's make a division by 0. This is what to show you now. So if I, for example, instead of using this, I use R bar 2 like this, and I'm not going to specify anything here. I'm going to connect. Online change. PLC is in run. Okay. Then I'm going to define this value 0. Okay, was an online change, not on low, so I'm going to modify this. So now we can see the behavior. You can see here, this one is in yellow, indicating there is something wrong. Okay, program load exception. If we go over here, this will be the problem, and it doesn't matter if I start and run, it just doesn't allow me because we have an error here. So there is a few stuff to do here to check what is the problem. Okay, what I'm going to show you later. Okay, right now we know that application error, we know that this is the problem, it's a division by 0, and if you want to avoid this part, okay, what we have are some POU explicit checks. This one, so I'm going to use add folder auxiliary, and in here we're going to call this POU for implicit checks, division checks. So it will check the division by 0. In my case, I'm using a real variable. So real, if the division is 0, then it divided by 1. It replaced that, but I want to indicate a fault. For example, GBL, this one is already defined, alarm division by 0, so I can call this one GBL dot alarm division by 0 is gonna be true. Okay, and if it's not, I'm going to put it as false. Okay, so now let's make some modifications here. I don't want to start with 0, I just want to start with 1. I'm going to force the value. So now, yes. Yes, I want to perform for the load. And here. So good. So you can see the program is running. Here, 2 divided by 1, 2. Now I'm going to change this value to number 0. Okay. As you can see, the PLC is still run, but the variable I have defined that the error isn't true. So here, what you can do is to make this POU for explicit checks. So you can define an internal variable and define the system fault or something similar, just to give an idea that you are making a division by 0. Okay, so now if I replace this, let me just select vertical. If I change this by, I don't know, 6 or whatever, here the error should be disappear. Okay, so let's give you an idea that the PLC could have been in error, but based on, thanks to the implicit checks, the PLC is still run. Okay, otherwise if I delete all this, then the PLC will be on stop due to this. Okay, so I already covered this part and simulate the behavior. Okay, so everything I want to show you is already done. As you can see here, if you need to make a formula or something, I strongly recommend to use structure test rather than ladder. It's going to be a long instruction that you need to do. But if you're still field control with ladder or CFC, just go on. Okay, so thank you very much for watching this video, and I see you on the next one.